Good morning to one and all. I'm Dr. Nishant Sharan, designated as Assistant Professor in Madanapalle Institute of Technology and Science. I'm here to deliver a topic on electrostats, a topic which we study first time in our school level physics and in the some of the engineering courses like electronics and communication engineering having a paper called as electromagnetic and field theory. So I would like to cover this topic starting from the basics till to the engineering level concept. After going through this video lecture, you would be able to visualize conceptually the concept of electrostatics. You would be able to solve the problems related to the electrostats. Before I start the topic, I owe my heartiest gratitude to the Department of Electronics and Communication Engineering, Madanapalle Institute of Technology and Science, for giving me this opportunity. So let us start. The topic electrostats. If you see this word electrostats, it is composed of the two words electricity and statics. Means electricity, which is simply a synonym for charge. So the topic which we are going to look forward is the what is the behavior and phenomena of the charge at rest. So this is the first thing we are going to look for. My flow of presentation consists of electric charge. I would be discussing the basic fundamental of electric charge. Then very important and fundamental law given by the very known physicist Mr. Coulomb. So Coulomb's law of electrostats, you will enjoy it here with the problem. Then if the time permit, I will move to the electric field. Maybe in the upcoming lecture, we will be going through the very important law called as the Gauss law and its application. So the time being, as you can see on my slide, the daily life example of charge. In our childhood, many of us have played it. You rub your a comb with a dry hair. So what happens? When you rub a comb with a dry hair, the comb gets charged. So some of the electrons from our hair get transferred to the comb and it becomes negatively charged. When you bring this comb to the small bits of the paper, so the positive charges on the paper gets accumulated near to the comb and the negative charge remains away at the other end. So what happens when you bring the comb near to the bits of the paper? It is having a force of attraction. As you can see on my slide, as a person is bringing this comb near to the bits of the paper are getting attracted. Another example, another very simple example, if you rub a rod with a piece of the cloth, the rod gets charged. What type of charge will be developed? The question is there. Then, if you see, it depends upon the nature of the material of which the rod has been made. Yes, if it is a glass rod, it will become positively charged. If it is a plastic rod, it will become negatively charged. So all this type of phenomena we can observe in our day-to-day life at our home. So once we have got the concept that transfer of electron, if electrons are more in number, the material gets negatively charged. If electrons are less in number, it becomes positively charged. So let us talk on the fundamental unit, that is a charge. So just like the mass, charge is a fundamental quantity of any substance. Yes, as one cannot define the mass, similarly one cannot define the charge. But we can study the properties of charge, what are its characteristics, So fundamental charge is the defined as charge on one electron, which all of us know from our basics of the physics and chemistry that charge on one electron is minus of 1.6 into 10 to the power minus 19 coulomb. So coulomb is the unit of the charge. Then moving forward, there, as I mentioned, there could be the two types of charge. One is the positive charge. So positive charge simply indicates that there is a shortage of electrons. That is what is the point here is the shortage of electrons. So if you see what I mean by the shortage, that it is having the less number of electron in comparison to the protons. That is what. Then if I talk about the negative charge, it is excess of electrons. Excess means it is having the more number of electrons in comparison to the protons. So in that case, the body is said to be negatively charged. Then, but overall, the very important and the fundamental principle we all know, like energy, energy can never be created nor be destroyed. Similar is the funda for the charge. Yes, you can never create a charge, you can never destroy a charge, but yes, whenever you rub a body or some other mechanism, you can always transfer the charge from one body to another. So the net charge in a closed system will always remain constant. It can never be created nor be destroyed. Please keep in mind, it always remains constant. That is the most fundamental thing. Just like the conservation of energy, charges follow the conservation of charge. Then, coming to the point, as we have seen in the previous slide, that when you bring a comb near to the bits of paper, the papers are getting attracted. So there is a force of attraction between the comb and the paper. So whenever there are the two charged body, they exert a force, electric force on each other. So how to measure the magnitude of that force? They will always exert a force on each other. How can you measure that force? That was given by the person and the physicist called as Coulomb, a very fundamental law called as the Coulomb's law of electricity or Coulomb's force of attraction. So see, before we go for the Coulomb's law, we should know what? That like charges, they always repel each other. That is what you see. If I'm having the two positive charges, they will repel, it will go away from each other. But if you are having the two unlike charges, one is positively charged, another one is negatively charged, they will attract each other. As you can see this arrow, the this negative charge is going towards the positive charge, whereas this positive charge is going towards the negative charge. So please keep in your memory that like charges, they always repel each other. Unlike charges, they always attract each other. Then coming to the back to the force of attraction or repulsion. It was framed by Coulomb. He gave a law. He said that if you are having the 2 point charges, Q1 and Q2, if you are having the 2 point charges Q1 and Q2, and these point charges are separated by a distance d. Now here I'm using a word point charge. What I mean to say by this specific term point charge? Let us try to understand. The point charge means magnitude of this charge is such that uh, that if it is kept on any body, the physical dimension of that body is negligibly very small in compared to its surrounding object. So for example, let me illustrate it. For example, there is one paper pin. On the tip of the paper pin, if charge is there, so you can imagine the tip of the paper pin is very small. So that dimension of the tip of paper pin is negligibly small in comparison to the surrounding. So that is the meaning that on that tip, the point, the charge which is residing on the pin of that paper pin, point on the pointed pin of the paper pin is called as a point charge. It will behave as a point. So whenever the 2 point charges are separated by some distance d, the force of attraction or repulsion, if they are of the like charge, they will have the force of repulsion. If they are unlike charge, they will have the force of attraction. So force of attraction or repulsion between them is directly proportional to magnitude of product of charges and is inversely proportional to a square of distance between them. This is what he said. So F is magnitude of the force is directly proportional to product of the charges and inversely proportional to a square of distance between them. So if I rewrite it, I will have to put a proportionality constant K to remove this proportionality sign. So it becomes F is equal to K Q1 Q2 by R is the, if R is the distance, R is square. If D is the distance, it is D square. That's not a problem. And then force is actually a vector quantity. If you see very carefully, force is a vector quantity. So I need a direction of this force. So direction of this force is always along the line joining these two charges. Please be careful, be noted that direction of this force is always along the line joining the two charges. So that is why if r is the distance, the direction is AR hat. That's the important. So the final expression becomes K Q1 Q2 AR hat cap over RS square. The letters which I'm representing in my slide with the bold are representing the vector quantity. As you can see, I'm representing the force as a with the bold face letter, so it is representing a vector. And AR hat is a unit vector. That's very important. The AR hat is a unit vector along R. So we will see more in details about this unit vector in the upcoming slides very soon. So that is what I mentioned. Then another important point you can see, this law is also known as inverse square law. Why? Because very easy, because the force is inversely proportional to the square of distance. A square of distance, please be noted, not the inversely proportional to the distance, it is always inversely proportional to a square of distance. So moving ahead, just we will see some more points. As I told you, that force between the charges is inversely proportional to a square of the distance between them. Then let us see one example. Suppose if you double the distance and reduce the force. So if I double the distance, means my initial distance is r, and now I make the distance as the 2r. So if I double the distance, my force will reduce by 1/4. So force will become 1/4 of its original value. So the next point is that, as I told you already, that this relation is called as inverse square law. So force and distance are allowed an inverse square relationship. Let us see some more insight on this. Say, the force between the charges is directly proportional to magnitude or amount of each charge. Yes. So if suppose initially the charge was Q, or suppose Q was 2 microcoulomb. Now I make the Q1 was 2 microcoulomb. Now I make this Q1, for example, as 4 microcoulomb. So this is just nothing that I have just doubled the magnitude of Q1. So what will happen? If I have doubled the magnitude of one of the charge, my force will become double. Suppose somebody is saying that Q2 is 6 microcoulomb. I make it double. I make it 12 microcoulomb. So now Q1 is 4 microcoulomb, Q2 is 12 microcoulomb, Q1 has been doubled, Q2 has been doubled. So what will be the final effect on the force? Think of it. Give a pause, think of it for a moment. So it's very easy. The net force, the new force F prime will become 4 times the original force, because you have doubled both the Q1 and Q2. So like this, the Coulomb's law behaves. So now let us see, describe the one question for you. You can read the question, you can think over it, and then you can answer it. Describe the changes to the magnitude and direction. Here are the keywords which you need to focus on the discussion. Magnitude and direction of the force on one of the charge in an electric dipole when the distance between the charge increases. See what the question is saying. Question is saying that you are having an electric dipole. So electric dipole means two charges are there. Electric dipole is simply that this is the two charges are there. One is Q1, maybe positive, another is the minus of Q2. So this system is called as a dipole. So now it is saying that if the distance is increasing, what will happen to the magnitude and direction? Definitely, if we increase the distance, what will happen? So as we increase the distance, force will decrease. And will there be any effect on the direction? Not at all. Direction will remain same, but with the increase in the distance, the force will decrease. Definitely. Then continuing forward, force between the two charges gets stronger as the charge moves close together. That's understood. Then it will get stronger if the amount of charge becomes large, already illustrated with an example. Now, coming to the main aspect and the last aspect of this Coulomb's law. Now, in engineering standard, we study a coordinate system. Now, what is coordinate system? Let me recall for you. You can go through it. You can study it using any of the book or any of the uh, e-content available on the YouTube or any other channel. So now the coordinate systems are used to locate the position of the charge. So what will happen? So what will happen is that if I'm having a charge Q1 and this is located at a point -3, 7, -4, and there is another charge which is located at point 2, 4, -1. Now what I mean to say by -3, 7 and -4 means distance from origin to the x-axis is -3, distance from origin to the y-axis is 7, distance from origin to the z-axis is -4 for the charge Q1. Similarly, distance from origin to the x-axis is 2, distance from origin to the y-axis is 4, distance from origin to the z-axis is -1 for the charge Q2. And now the question is asking, find the force on Q2 due to Q1 and force on Q1 due to Q2. So we will use the Coulomb's law. And what does the Coulomb's law say is that? Coulomb's law very easily says that force is K Q1 Q2 by R square R cap, right? Yes. But here you may be wondering why I'm writing like this 1, 2. Here also 1, 2. Here also 1, 2. Why? What is this? Yes, what I'm writing is that we am following a nomenclature. What sort of nomenclature? The nomenclature is that when I'm writing 1, 2, this indicates force on Q2, means charge 2 due to Q1. If I write F21, so the last script, whether I'm writing FAB or F12 or F21, so that is the final point which is experiencing the force. And the first one is the cause due to which it is experiencing the force. So F12 or F21. So when I say F21, so F21 is force on the 1. Listen very carefully. Force on the charge 1 due to presence of charge 2. When I say F12, force on charge 2 due to presence of charge 1. That is the reason. So now you see, when I am saying F12, I will have to find R12. Now what is R12? R12 is R2 minus R1. That is a vector concept, final minus initial. And what is R12 cap? That is similarly any vector, unit vector is R cap is vector by its magnitude. So we are having R12 hat is R2 minus R1 by R mod of R2 minus R1. So now if you find what is the R2 minus R1, so it's very easy to find what is R2 minus R1. So what I will write for R2? But this is my simply the Cartesian coordinate system. So see, you might have studied that for x, y, z at your school level physics, we are writing I cap, j cap, k cap. Here also we are writing I cap, j cap, k cap. But in the engineering level, we used to write ax hat, ay hat, and ag hat. So, so that is what I'm going to write here. If you say, if I write here R1, R1 is minus of 3 AX hat. At engineering level, we write I cap as AX hat plus 7 of AY hat minus 4 of AZ hat. This is just similar to I cap, J cap, K cap, which you have studied at your school level physics. Similarly, for R2, one can write, what one can write? One can write 2 of X, yes, you are right, plus 4 of AY, yes, minus of AZ hat. That's very easy. Then one can find here R2 minus R1, which is pretty easy. When I write 2 minus of minus 3, this becomes 5. That's pretty easy. When I write 4 minus of 7, becomes minus of 3. Again, it's pretty easy. And when I write minus of AG, minus minus becomes plus. So this becomes plus of 3 AG hat. So I'm writing R2 minus R1, which is very simple. And then it's very easy to compute mod of R2 minus R1. Yes, you can think of it how to do it. It's very easy. What we do, we take the square root and we square the each component and we add them. So if I square the 5 square plus 3 square plus 3 square, thus I believe is very obvious to all of you. This becomes 25 plus 18, which is square root of 43. So we have got the expression of R2 minus R1. We have got the mod of R2 minus R1. Then it is very easy to find R12 hat. You just plug in all the values and you can calculate the F12. This is a task I'm leaving to you. You can work it out and you can find it. So this is just for the time being. I'm just leaving to for you all. You do it. If any queries, you can put your queries here. Uh, in the next session, I'd like to see the responses for the F12. Also, I will give you the solution to the F12. Meanwhile, you can post your queries here. Thank you. We will hope the next time we meet, we will carry on from here itself. Thank you.